Hey everyone, Mr. Lambert here with our first lesson of Cycle 1B. We're going to be focusing on a new content standard, which is 6.c.2. And all this standard says in math is that I can fluently compute or use addition, subtraction, multiplication, and division with positive fractions and decimals. So we're going to be dealing with fractions and decimals and using all of our basic operations. To start that out, we're going to deal with two parts of numbers that we're going to need as we deal with each of the different operations with fractions and decimals. We're going to have to know the factors and multiples of each number. So we thought we would review that with you today. So a definition of a factor. If you're in Mr. Lambert's class, grab out your vocab binder and put this definition down. Factors are any of the numbers that when multiplied together form a product. So like 5 and 3. If I multiply those together, I get the number 15. 15 is my product, so factors of 15 would include 3 and 5. Some other examples. Well, 2 times 4 equals 4. 4 times 1 equals 4, and 1 times 4 equals 4. That means that 1, 2, and 4 are the factors of 4. Non-examples. Well, 4 times 2 does equal 8, and 4 times 3 equals 12. But 8 and 12 are multiples of 4, not factors of 4. When do I use factors? Well, factors are super helpful when we are renaming and simplifying fractions. We will need those as we rename fractions and simplify them going forward. The next definition is multiples. Go ahead and write that down in your journal. The definition of a multiple is multiples are the result of multiplying any two integers or non-fraction numbers together. So again, adding any two non-fraction numbers together will give you they are the multiples of whatever number. So let's see here. 3 times 1 equals 3. 3 times 2 equals 6. 3 times 3 equals 9. So 3, 6, and 9 are the multiples of 3. Whereas before we were looking at the two numbers that we could multiply together to get a product for the number we're looking for. These are our number and then multiplied by something else. A number will have an infinite number of multiples. That means you can just keep multiplying by things larger and larger and larger and larger than themselves and getting more multiples of that number. So non-examples, again, 1 times 3 equals 3. 3 times 1 equals 3, but that means 3 and 1, they're not multiples. Those would be the factors of 3. When do I use multiples? Well, they are super useful when I'm converting fractions to mixed numbers and decimals to percentages. These are both things we'll be doing in the coming weeks. So, ladies and gents, first question for you. Try this with me. What are the factors of 12? Again, you need to think through what numbers can I multiply together to get 12? I'll give you just a second. Type your numbers in on the side and see how you did. Here are your factors. 1 times 2 is 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And then, of course, their inverse. 4 times 3 is 12. 6 times 2 is 12. And 12 times 1 is 12. So we look at each number that can only appear one time. So the factors of 12 are 1, 2, 3, 4, 6, and 12. On the other hand, multiples. So again, any number will have an infinite number of multiples. But think of the first 4 multiples of 7. Go ahead and write them down, type them in on the side here, and then I'll check them with you here in just a moment. So the first 4 multiples of 7 are 7 times 1 equaling 7, 7 times 2 equaling 14, 7 times 3 equaling 21, and 7 times 4 equaling 28. So there are your first 4 multiples, 7, 14, 21, and 28. And that's all you have, ladies and gentlemen. So right below, you're going to have a couple of practice questions to see how you do figuring out factors and multiples of each number. Again, this is a skill we have to have in order to be able to go on and add, subtract, multiply, and divide these numbers. So give them a shot, and we'll check them here in just a moment.